Hi, I'm Scot Schultz with Mellanox, and I manage the HPC and technical marketing activities for Mellanox. Is this going to move forward? Okay. So most of you are already familiar with Mellanox and the hardware that we provide, but what you might not be familiar with is a lot of the host and fabric software packages that we have. And so I think it's okay to tell you tomorrow we'll be introducing a new package called HPC-X. It's a scalable HPC software toolkit. I have a few slides to talk about that here in just a few minutes, but we'll also talk about Peer Direct, GPU Direct, and then before we do that, I want to go into basically this is just the general roadmap here of excuse me, I need to, hey, I'm gonna borrow some water. A general roadmap of the technology that Mellanox marches to. You're basically here, whoops, laser. You're basically here where we're fastly embracing 100 gigabits a second technology. So, you know, with all of this data explosion and a lot of the talks that we've already had this morning, with the amount of devices that are connected to the internet and you know, billions of devices, and with the SKA and the amount of data that we're moving, you know, it's basically really about enabling the use of data, and I think that's a large part of Mellanox's focus. So just talking about ConnectIB. ConnectIB is our current generation of FDR devices. It's actually the world's first 100 gigabits a second interconnect adapter. You're actually able to push 100 gigabits plus through this adapter utilizing dual ports of 56 gigabit over PCI Express Gen 3 by 16. So 137 million messages per second. It's about 4x higher than any other device that's out there. And it includes support for a new innovative InfiniBand scalable transport called DCT. And I think you'll hear more about that from Rich's talk a little later this afternoon, and you heard quite a bit of it already from DK Panda, so I won't spend a whole lot of time on that. This is a chart that you've seen also, so DK, you steal my thunder every time I get up to present and you precede me. But so these are DK's results here, taking a look at the performance that you can get out of the ConnectIB on the Ivy Bridge type platform. So 12.8 gigabytes a second, and then bidirectional bandwidth is almost 25 gigabytes a second. And so how does that translate into performance? So these are a couple applications that we've taken a look at in our labs. Win2K and the weather modeling code, the WRF application. So you know, taking a look at the red line, you can pretty much just ignore the red bar. The Express Gen 2 kind of QDR interconnect solution just completely falls flat for performance across just about all applications. But just focusing and concentrating on the blue lines here, where you can see that ConnectIB, and by the way, these performance numbers are port to port. We're not using two ports of ConnectIB against one port of the other devices. This is a very fair comparison of ConnectIB FDR against the ConnectX3, our previous generation FDR as well. So you can see that there's considerable performance improvement from the new ConnectIB device. Okay, so Mellanox Peer Direct, and I don't know if any of you have heard of Peer Direct. Most of you have all heard of GPU Direct RDMA, and we heard that from DK earlier. But so Mellanox Peer Direct is basically inherently part of the Mellanox OFED 2.1 distribution, or later. So our latest distribution is 2.2, which I believe is available on our website today. And this is basically the overall architecture that supports the peer-to-peer communications between the Mellanox adapters and just about any third-party device. So if it's a third-party device and it actually has memory on it, it could actually sit on top of the peer-to-direct architecture. And so we have native support for the Intel Xeon Phis. And I believe that Intel will be announcing the NPSS software stack 3.2. I think this month is when that's due out, and that supports the Mellanox OFED very nicely. So there's no more of the kind of Open Fabrics mic beta package that you're going to have to deal with. And it also supports, as well, of course, NVIDIA GPU Direct RDMA with a separate plugin, and that's available on the Mellanox.com website. So we just introduced that into the wild as GA just a few weeks ago, actually. So it supports not only InfiniBand transport, but it also supports Rocky over our VPI devices, so ConnectX-3, ConnectX-3 Pro, as well as the ConnectIB adapters. All right, so this is just basically a functional block diagram of Peer Direct and kind of what it looks like. So, there's basically a peer-to-peer plugin module that you load, and it provides the memory management features between the two devices. So you'll be able to map physical memory to virtual memory and provide the communication layer between the independent devices across the fabric. So an example of that is GPU Direct RDMA. So for those of you who are not familiar with GPU Direct RDMA, this is just a single kind of a snapshot slide that basically said, a couple years ago, the evolution of GPU Direct RDMA before GPU Direct came along, that basically that the network as well as the third-party device drivers, such as the GPU, they didn't share any kind of buffers, right? So they needed to make a redundant copy in the host memory. And that was not only true for the local node, but as well as the remote node. So basically you were doing a lot of redundant data copies. And so in working with NVIDIA, we introduced what was called the first version of GPU Direct RDMA with the shared host memory pages, and this basically allowed the GPU and the network driver to share the pin buffers, eliminating that need to make an additional copy in system memory. So then, we just released GPU Direct RDMA out into the wild here, and fundamentally that gives you the capability to take this third-party device like NVIDIA's GPU and talk directly to a remote peer GPU across the InfiniBand fabric. So, this results in significant improved MPI send and receive efficiencies between those GPUs and the remote nodes. And DK presented a bunch of slides, performance slides. Brian, I thought you updated my slide deck, but that's okay because DK actually showed you the performance up to like 65% reduction in latency for small message sizes, and 5x bandwidth improvement for the larger message sizes. But one of the considerations, and if you're playing with GPU Direct or you're trying to deploy GPU Direct RDMA, basically make sure that they're sharing that same I/O root hub, the I/O complex, or using a PCI switch device. So these are just another look at HUMD Blue. That does seem to be the flagship application these days for GPU Direct RDMA, but it was developed by the University of Michigan. And so it's a general purpose molecular dynamics code that was written from the ground up to just run on GPUs explicitly. So we demonstrate over 100% performance with a larger number of particles, and this data actually came off of the University of Cambridge. So but as well as, for the smaller 16K particle sizes and whatnot, just with the handful of nodes that most developers are actually playing with GPU Direct today have, you can get about over 20% performance with just a handful of nodes. Okay, so the drum roll around HPCX. So I've been spending a lot of time trying to deploy or find a better deployment mechanism for a lot of the HPC tools that Mellanox offers. HPCX is basically a package of communication libraries. We support, it's based on the Mellanox MPI, which is based on OpenMPI 1.8, support for SHMEM, UPC, PGAS. as well as we tightly integrate all of the features in our acceleration hardware, or software, I'm sorry, that MXM and FCA, the Fabric Collective Offload and the point-to-point library MXM, which basically take advantage of the core direct that is exposed through our drivers in the Mellanox OFED stack. And so the idea as well is to kind of introduce HPCX into this into the stack here, and the Mellanox hardware is very much I guess you'd say it's interoperable or future-proofed, right? So we have compatibility across SDR, DDR, QDR, FDR. All the devices kind of work. They mix and match. So we kind of want the software to be exactly similar to that. So future-proofing the software compatibility across the different generations of hardware is very important as well. Keeps it very much easy to deploy. So there was another slide, but this basically sums it up. So what are the components of HPCX? Basically all of the communication libraries that I mentioned. So there's Mellanox Scalable MPI, which is based on MPI, OpenMPI. The enhancements to Scalable SHMEM and UPC. So these are all going to be bundled and tightly integrated into one easy-to-deploy package. It includes the acceleration libraries I mentioned, MXM and FCA. And then we'll provide a number of other tools, IPM, the integrated performance monitoring tools, all of the MPI benchmarks and their scripts and tools and everything that you need to actually tweak and tune your cluster for those of you who are actually eager to use and deploy an open source based MPI and software stack. Knowing that you're going to have a commercial company like Mellanox to back and support all of this open source software, right? So that's kind of one of the issues about using open source software. You never know where to go get support. And do you need to go to a forum, or do you need to go to an application vendor or whatnot? So so Mellanox is going to back and support this. This is very robust software. So this is just a few applications across CFD, CAE, bioscience. Apps, 20 to 70% performance, just depending on the type of application and the type of algorithms that you look at. Let's see. So this is basically just a snapshot of where MXM and FCA sit. Now, bundling the software and these particular accelerators inside of HPCX is very much easy to deploy, and it's very tightly integrated into the HPCX package, but both MXM and FCA are very much readily deployed by any of the other commercial MPIs that are out there, right? So it's kind of a generic type of architecture. You can bolt on FCA and be able to take advantage of the Fabric Collective Offloads. So remove all of the communication from the processor and free up all of that system jitter to actually do real application work and put it on the network. That's kind of the goal here. So that doesn't go away in those two independent packages. If you're using an IBM MPI or Intel's MPI, you can get these independent packages as well from the HPC software section of the Mellanox site. Okay, so this is probably the final slide. So FCA collective scalability. We've been taking a look at what is the benefits of FCA across various. So this is a barrier and reduce, a couple of the collectives there. Drastic latency benefits by offloading it from the processor. As well as additional bandwidth across the various other collectives like 8-byte broadcast and whatnot. So increases your CPU efficiency, minimizes the negative impact of all of that system noise and jitter. So it's good stuff. And stop by the Mellanox booth and we'll have some additional slides that weren't included in this deck. And you can talk to me about getting the package. I believe it's deployable today. It should be on the Mellanox website. It's just download it. So that's that. So any questions? I know I'm standing between you and lunch. I always seem to stand between you and lunch in my presentation slots.
HPCX available now?
It's available now.
Now. Okay.
But don't post his videos until next week. Under embargo until, or I'm sorry, it is next week. But I think tomorrow is when we're going to announce it and release it. But yeah.
All right.
Cool. Thanks, Brian.